Building an app powered by generative AI is hard. You might have a great idea for a product that uses Landa's models, but turning it into a production-ready service is hard. It takes time and money and, most importantly, people. And not just any people. People with very specific skills that are in high demand and therefore also expensive. In this video, I want to show you 4 different ways to scale your generative AI experiments into production. And at the end of this video, I will also share with you how to build an MVP faster so that you can get feedback from real users as soon as possible. Welcome to the channel. The first option to scale your generative AI experiments into production is to use platforms like AWS, Google Cloud, or Microsoft Azure. They offer managed machine learning services where you can train and deploy your model and then scale your application using their infrastructure. For example, with Amazon SageMaker, you can train your model using a notebook and then deploy it as a real-time endpoint or as a batch transform job. You don't need to worry about provisioning servers or managing infrastructure. This option is great if you want to focus on building your application and leave the scaling and infrastructure management to someone else. However, this option may not be the most cost-effective solution in the long run, especially if you need a lot of GPU power to run your models. The second option to scale your generative AI experiments into production is to use self-managed Kubernetes. With this option, you have full control over your infrastructure and you can run your models on GPUs or TPUs in a way that scales automatically. You will need some expertise in DevOps and site reliability engineering, but this option gives you a lot more flexibility and control over your infrastructure. One popular tool for self-managing Kubernetes is kubeflow. It's an open source machine learning operations platform that enables you to train, deploy, and manage machine learning models in a Kubernetes environment. kubeflow provides tools for experiment tracking, model versioning, and hyperparameter tuning, as well as tools for deploying models as REST APIs or webhooks. Another option is to use Argo ML. It's an open source machine learning operations framework that integrates seamlessly with the rest of the Argo CD ecosystem, allowing you to implement continuous integration and continuous delivery pipelines for your machine learning projects. Argo ML supports training and deep learning frameworks like XGBoost, LightGBM, Keras, PyTorch, and TensorFlow. The third option to scale your generative AI experiments into production is to use edge functions. Edge functions allow you to run code in a distributed environment that is close to your users. This can improve the performance and scalability of your application. For example, with Cloudflare Workers, you can write code in JavaScript and run it at the edge. The fourth option to scale your generative AI experiments into production is to use serverless functions. Serverless functions allow you to run code in a serverless environment where you don't need to provision or manage any servers. This can be a cost-effective solution for running your models as they only get executed when you actually need them. For example, with AWS Lambda, you can run Python or Node.js code without managing any servers. AWS Lambda supports various machine learning frameworks such as TensorFlow and PyTorch, and you can also use tools like SageMaker to easily deploy your models to Lambda. Similarly, Google Cloud Run is a fully managed serverless platform that supports containerized applications. You can deploy your models as containers and scale them automatically based on demand. Google Cloud Run integrates with other Google Cloud services such as Cloud Storage and Cloud SQL, and supports various machine learning frameworks such as TensorFlow and Scikit-learn. Now that you know the 4 options to scale your generative AI experiments into production, the next question is, how do you choose the right one for your application? Well, the answer depends on various factors such as the type of model you're using, the amount of data you're processing, the required latency and throughput of your application, and your budget and expertise. Now let's compare the pros and cons of these 4 options. Using managed machine learning services from cloud providers is easy to get started with and scales automatically, but can be expensive in the long run and may not offer the level of control you need. Self-managed Kubernetes offers more flexibility and control, but requires more expertise and effort to set up and maintain. Edge functions are good for applications that require low latency and high throughput, but may not be suitable for applications that process large amounts of data. Serverless functions are cost-effective and scale automatically, but may not be suitable for applications that require a lot of compute power or have unpredictable workloads. Now let's dive deeper into how you can build an MVP faster and get feedback from real users. Building an MVP doesn't mean cutting corners and making a crappy product. It means focusing on the core value proposition of your product and delivering it to users as soon as possible. Here are 3 tips to build an MVP faster. First, use no-code tools. No-code tools allow you to build applications without writing code. This can speed up your development process and allow you to iterate faster. For example, with tools like Bubble or Adalo, you can build web or mobile applications with visual interfaces and pre-made components. Second, use pre-trained models. Pre-trained models are machine learning models that have already been trained on large datasets and can be used for various tasks such as text generation, image classification, or object detection. Using pre-trained models can save you a lot of time and effort, as you don't need to train your own models from scratch. For example, with tools like Torch Hub or TensorFlow Hub, you can access pre-trained models for various tasks with ease. Third, use APIs. APIs allow you to access the functionality of other applications or services without knowing the underlying code. This can help you integrate various tools and services into your MVP faster. For example, with tools like OpenAI's API or Google Cloud Vision API, you can integrate generative AI functionality into your MVP with ease. By following these tips and using the right tools, you can build an MVP faster and get feedback from real users sooner. Remember that the goal of an MVP is to validate your idea and get feedback, not to create a perfect product. Once you have validated your idea and have feedback from real users, you can then iterate and improve your product. To recap, there are 4 options to scale your generative AI experiments into production: using managed machine learning services, self-managed Kubernetes, edge functions, or serverless functions. Each option has its pros and cons, and the best option for you depends on your specific requirements. Additionally, you can build an MVP faster by using no-code tools, pre-trained models, and APIs. These tips can help you get feedback from real users as soon as possible. If you enjoyed this video, please hit the like button and subscribe to the channel. Thank you for watching, and I will see you in the next video.